The topic is simplifying algebraic expressions, and the objectives in this topic are use properties of numbers to combine like terms, use properties of numbers to multiply expressions, simplify expressions by multiplying and then combining like terms, and find the perimeter and area of figures. A term that is only a number is called a constant term, or simply a constant. A term that contains a variable is called a variable term. So x plus 3, the constant term, would be 3. 3y squared plus negative 4y plus 2, the constant term would be 2. The sign in front goes with it. So that is a plus 3 from the left. That is a plus 2 from the right. The variable terms would be x, 3y squared, and negative 4y, the terms that have variables in them. Previously, you might have heard me talking about the number in front of the variable. In front of this x, we can imagine that there is a 1. 1x is a single x. 1 times x is x, because anything times 1 is itself. We always write 1x as just x, but we know there's an imaginary 1 there. There's a 3 in front of this y squared. There's a negative 4 in front of this y. The number factor of a variable term is called the numerical coefficient. And like I said, the numerical coefficient of 1 is usually not written. So 5x has a coefficient of 5. X is 1x. The understood coefficient is 1. Negative 7y, the coefficient is negative 7. The sign comes with it. The sign is part of the coefficient. The coefficient of 3y squared is 3. Now, terms that are exactly the same, except they might have different numerical coefficients, those are called like terms. So the same variables raised to the same powers are like terms. 3x and 2x, they both just have x to the first power. Negative 6y, 2y, and y, they all just have y to the first power. Negative 3 and 4, they're constants. They both don't have variables. Some examples of unlike terms would be 5x and x squared. They are both x's, but they're to different powers, so they are not like terms. 7x and 7y. The fact that the 7s are the same have nothing to do with it. The variables are different, x and y, so those are not like terms. 5y and 5, again, the common 5 has nothing to do with anything. 1 is a variable term, 1 is a constant term. They can't be like terms. 6a and ab. They both have a, but just like x and x squared weren't the same thing, a and ab aren't the same thing. B is an extra variable that one has that the other doesn't. They cannot be like terms. The order of the variables does not have to be the same. So for instance, 2ab squared and negative 5b squared a, those actually would be like terms. They both have a, they both have b squared. The order doesn't matter because order doesn't matter when we multiply. Let's review the distributive property. I warned you that once we get to x's, the distributive property would be important, and we would need to know that AC plus BC, for instance, is A plus B times C. AC minus BC is A minus B times C. And that goes both ways. If we have A plus B and we're multiplying by C, A times C plus B times C would be true. If we have A minus B and that's times C, A times C minus B times C would be true. Previously, we saw this as A times B plus C and A times B minus C. But the thing that gets multiplied through can also be on the right side. It doesn't have to be on the left. We were used to eliminating the parentheses, but in this form, we're kind of writing it with parentheses. And there's going to be a point to that. You're going to see that. This example should clear up why this form of the distributive property is going to be useful for us. It says that 7x plus 5x would be 7 plus 5 times x. And we know 7 plus 5 is 12. So 12 times x, 12x. That's how we know that 7x plus 5x is 12x. The distributive property is working in the background. I like to simplify this, though. Instead of thinking about it like the distributive property, I like to think of them as things. For instance, apples. 7 apples plus 5 apples is 12 apples. But instead of apples, we have x's. 7 x's plus 5 x's is 12 x's. This is an example of combining like terms. And we say that an algebraic expression is simplified when all like terms have been combined. So let's practice and combine like terms. 8y plus 4y, 8 of them plus 4 of them is 12 of them. In B, y minus 6, y is the same as 1y. So 1 of them minus 6 of them is negative 5 of them, negative 5y. In C, we can't do anything with that minus 3, but we can combine the x squareds. 4 of them plus 6 of them is 10 of them. 10x squared minus 3. Let's recall we had some addition and multiplication properties. We had the commutative properties that say we could add or multiply in any order without changing the value. The commutative properties were the properties where we pick up and move. We change the order. So A plus B equals B plus A, and A times B equals B times A. The commutative property is the ABBA property. Meanwhile, we have the associative properties that say that the groupings can be changed. We can put parentheses around different pairs of addition and different pairs of multiplication and still get the same answer. So if we're adding A plus B plus C, it doesn't matter if we add A plus B first or if we add B plus C first. When we add that third thing onto the sum at the end, we will get the same answer. Same with multiplication. A times B times C. It doesn't matter if we do A times B first or if we do B times C first. When we multiply by that third thing, we're going to end up with the same answer either way. So some examples. 4 plus 3 equals 3 plus 4 would be the commutative property of addition. The order has changed. The numbers have moved. They've commuted. 6 times 9 equals 9 times 6 is an example of the commutative property of multiplication. Again, the numbers moved. They commuted. Hopefully they didn't get stuck in traffic. The associative property of addition, an example of that would be 3 plus 5 plus 2, where on one side we add the 3 plus 5 together first, and on the other side we add the 5 plus 2 together first. Either way, 8 plus 2 is the same as 3 plus 7, 10 equals 10. 7 times 1 times 8. Doesn't matter if we do the 7 times 1 first or the 1 times 8 first. 7 times 8 is the same as 7 times 8. That's an example of the associative property of multiplication. Why did we review these? Well, first, let's start by writing this as all addition. So instead of -3, that's plus a -3. Subtracting is adding the opposite. Now we have 4 things being added, and we can add them in any order. So let's change the order. Let's put the y's next to each other and the constants next to each other. Then 6y plus 4y, 6 of them plus 4 of them, is 10 of them. And 5 plus -3 is +2. So this simplifies to 10y plus 2. In A, we don't have to move anything around. The y's are already next to each other. 6 of them plus 12 of them is 18 of them. So 18y minus 6. In B, we can move things around. And to be technical, we can only do that when everything's addition. So the first thing we'll do is add the opposite, turning that -5 into plus a -5. Then move them around so that the y's are next to each other and the constants are next to each other. 7y plus y. 7 of them plus 1 of them is 8 of them, 8y. And then -5 plus 8 is 3, 8y plus 3. -7y plus 2 minus 2y minus 9x plus 12 minus x. They're getting larger. They're getting more complicated. There's more to do. We see that we have some y's, we have some x's, we have some constants, and we need to combine the y's. We need to combine the x's. We need to combine the constants. If we're going to start moving things around, a good idea is to start by writing everything as addition. So -7y plus 2 plus -2y plus -9x plus 12 plus -x. And then move the things around so that the y's are next to each other, the x's are next to each other, and the constants are next to each other. Then we combine. Let's do x's first, just because x comes before y, alphabetically. -9x plus -x. -9 plus -1 is -10. So -10x. And then we have -7y plus -2y. That's -9y. Finally, 2 plus 12 is 14. And we wouldn't write it -10x plus -9y. We would simplify that because plus a negative is the definition of subtraction. So -10x minus 9y plus 14 is how we would write the final answer. We could also use the distributive property to multiply expressions. So this is the form of the distributive property that we're most familiar with coming into this topic. If we had 2 times 5 plus x, that's 2 times 5 plus 2 times x. And we can simplify that to 10 plus 2x. If we have 2 times 5 minus x, that's 2 times 5 minus 2 times x, which can be simplified as 10 minus 2x. We don't need to use the distributive property unless we are adding or subtracting inside the parentheses. So in these two, this is 5 times y. This is 9 times x. We're not adding or subtracting, so we're not distributing. Instead, we would consider the associative property. We can't do 5 times y, but if we change where the parentheses are, we can do 5 times 5. 5 times 5 is 25, so 25y. Likewise, we can't do 9 times x because we don't know what x is, but we can change where the parentheses are, and we can do negative 8 times 9. That's negative 72. Negative 72 times x. But we can't do that moving the parentheses trick when we're adding or subtracting inside. Remember, the associative property is only good if they're all multiplication or if they're all addition. Here, we can't add x plus 5. We don't know what x is, but we still need to multiply. We still need to get rid of the parentheses. We do that with the distributive property. 6 times x is 6x. 6 times positive 5 is positive 30. So we express that as plus 30. We've done it. We've successfully distributed. We've gotten rid of the parentheses. We have multiplied. We have an equivalent expression. Negative 5 times 4a plus 3. Again, we can't add 4a and 3. We don't know what a is. We still need to be able to multiply. We still need to be able to get rid of the parentheses. We use the distributive property. Negative 5 times positive 4a. We can do that. That's negative 20a. Negative 5 times positive 3. That's negative 15 or plus negative 15. Negative 20a minus 15 is how we simplify that. Personally, I like to skip that second addition step. You saw how I said it. I said negative 5 times positive 4a is negative 20a. Negative 5 times positive 3 is negative 15. I jump straight to writing it as minus 15. But if you need extra steps, that is perfectly fine. So to simplify expressions, our first step is to use the distributive property first to multiply and then combine any like terms. So to simplify, 3 times the quantity 5 plus x minus 17. First, we get rid of the parentheses by distributing, by multiplying, and then we combine any like terms. 3 times 5 plus 3 times x. That's 15 plus 3 times x. 15 plus 3x. Plus negative 17. We're bringing that down. Or minus 17, however you have it. Combine like terms. 15 plus negative 17 is negative 2. So 3x plus negative 2. We write that as 3x minus 2. Just a note, that 3 does not get distributed to the negative 17 because that negative 17 is not inside the parentheses. We stop distributing when we hit the end of the parentheses. Next up, negative 7 times the quantity x minus 1 plus 5 times the quantity 2x plus 3. First step, use the distributive property to remove the parentheses. We multiply. We take what we have and we distribute the negative 7 to the x and to the negative 1. Negative 7 times x plus negative 7 times negative 1. Then we distribute the positive 5 through its parentheses. Plus 5 times 2x plus 5 times 3. Now we have some things we can simplify. Negative 7 times x is negative 7x. Negative 7 times negative 1 is positive 7. Plus positive 7 is just plus 7. Positive 5 times 2x, that's a positive 10x, so plus 10x. Positive 5 times 3, that's positive 15, that's plus 15. We have some like terms. Negative 7x's plus 10x's is 3x's. And then positive 7 plus 15 is positive 22, plus 22. Let's revisit the idea of perimeter. Recall, perimeter is adding all the sides. Here we have a triangle, and the sides are given in terms of z. 3z, 9z, and 7z. We want to add the 3 sides. We need the distance around the figure. So pick a starting point, and we add 3z plus 7z plus 9z. 3 plus 7 is 10 of them. 10 plus 9 is 19 of them. 19 of what? 19 of z, 19z. And we say that it's 19z feet because those were the units of the problem. And perimeter is a distance, so it needs to have units. Finally, let's revisit area. Area of a rectangle was length times width. Here, one of those is given as 3 meters, the other is given as 2x minus 5 meters. So when we multiply those, length times width, we get 3 times 2x minus 5. We need to distribute. 3 times 2x is 6x. 3 times negative 5 is negative 15, so 6x minus 15. And recall that the units here are square meters, because meters times meters are square meters. Remember, area is the stuff inside. And the stuff inside are how many squares that are 1 meter by 1 meter can we fit in there. And that is it for this topic.